Now we are going to take up more in current electricity. So just to recall, see, electric charge is denoted by Q. Electric charge is denoted by Q. Can be capital, can be small. You can use either of. See, we have two kind of charges. One is positive, other is negative. Opposite charges always attract each other, and same charges always repel each other. So if we need to measure amount of charge in body, we can actually measure by a formula Q is equal to NE. We can measure the amount of charge in a body by formula NE, in which N means number of electrons and E means charge on electron, which is a constant quantity, that is 1.6 into 10 raised to power minus 19 coulomb. And moreover, what is the unit for the charge? It is coulomb. As much of the information was revealed by coulomb, so therefore the unit of charge is kept behind its name, that is the coulomb. So that is what the unit for the charge, that is the coulomb. So if somebody asks you to define 1 coulomb, how you are going to define? See, 1 coulomb is that charge, 1 coulomb is that charge which contain 6.25 into 10 raised to power 18 electrons in it. 1 coulomb is that charge. If somebody asks you to define the SI unit of charge, that is coulomb, you are going to define in this way, that 1 coulomb is that charge which contain this much number of electrons in it, and we can actually prove it. See, suppose we need to find the number of electrons in 1 coulomb of charge. We know that E is 1.6 into 10 raised to power minus 19 coulomb, that is the charge on electron. So substituting the values, we have Q is equal to NE. N we need to find, so N is equal to Q upon E, that is 1 upon 1.6 into 10 raised to power minus 19. If you will solve it, it will come out to be 6.25 into 10 raised to power 18 electrons. So that is why we have defined that 1 coulomb is that charge which contain this much electrons, as we have already proved also that this contain this much electrons in it. So this is 1 coulomb. So that means electric charge is noted by this or this Q, either of, unit is coulomb. The formula to measure Q is Ne, that is the number of electron and charge on electron. So opposite charges attract and same repel. 1 coulomb is that charge which contains 6.25 into 10 raised to power 18 electrons in it. Now we are going to start with another topic, that is the electrostatic potential. Electrostatic potential or electric potential also you can say. Suppose we have any charge, let us say a positive charge. There is a charge which is present on a unit positive charge, I will write here, it is unit positive charge which is present on infinity. It is kept at infinity. We need to move this charge to a certain specific point, let us say A. There is a unit positive charge which is present on infinity. I need to move this charge to point A. Then that to move this charge from this point to this point, that means from unspecified point, that is infinity, to a specified point, then the work has to be done. And that work which is to be done in moving a unit positive charge from infinity to a certain specified point is an electrostatic potential. I am going to write the definition. So electrostatic potential is work done in moving unit positive charge from infinity to certain point is called as electrostatic potential. But for us the quantity which is means when we take two bodies, because here we need to move the charge from unspecified point to a specified point, but now we are going to move the charge from one specified point to the another. Here the one was unspecified and the one was specified, but now we are going to move so whenever you are going to move a charge from a specified point to another specified point, we convert this term into a potential difference. We convert this term into a potential difference. Suppose I have two bodies, let's say there is body A and there is body B. The difference between them is the number of charges. It contains more number of electrons and it contains comparatively less number of electrons, right. So that means the charge is going to, because it contains more number of electrons, we say that it is at high potential. We say that it is at high potential. Comparatively it has low number of electrons, so we say that it is at low potential. So the charge will move from high potential to low potential, and for this the work has to be done. So here the charge is moving from one specified point to another specified point, that is from A to B, and from high potential to low potential. So this is called as potential difference. So potential difference is work done in moving charge, work done in moving charge from where to where? From high potential to low potential, or you can say from a body at high potential to body at low potential. Yeah, or you can write we can work done in moving a charge from a point of high potential to the point at low potential. So putting in formula, if a potential difference is denoted by V, it is work done in moving charge. It is work done in moving charge. So it becomes V is equal to W upon Q, and from obviously from high potential to low potential. And if we put if we substitute the units, if we focus on the units, then the SI unit of potential difference is volt, work is, we already know, is joule, and for charge it is coulomb. So it comes out to be 1 volt is equal to 1 joule over 1 coulomb. 1 volt is equal to 1 joule over 1 coulomb. So if you need to define this, then don't cram the definition, you can just make it, you just write potential is said to be 1 volt, I will write here, potential is said to be 1 volt when you know that work is done. So we write when 1 joule of work is done in moving, obviously we are moving a charge, in moving 1 coulomb of charge from point at high potential to point at low potential is said to be 1 volt. So potential difference is said to be 1 volt, I will write here, this is potential difference. Potential difference is said to be 1 volt when 1 joule of work is done in moving 1 coulomb of charge from high potential to low potential. And there is an instrument definitely in order to measure potential difference, and that is voltmeter. Voltmeter is an instrument used to measure potential difference. So this is what is the device, that is the voltmeter. And if you want to denote it, how we denote it? With a symbol in circuit, V with circle around it showing the wires. So it is how it is denoted. So this is the device which is used to measure the potential difference in the circuit, and how it is applied in a circuit we will discuss later, because it is like when we connect it in circuit, we connect in parallel combination. And what is the reason we will discuss when we will discuss the circuit. So this is what is the potential difference.